All right, in this lecture, we're still talking about measurement, okay? So in our last lecture, we talked about accuracy, we talked about precision, and we talked about ways of calculating those out. So accuracy, we were able to calculate our percent error. Precision, we're able to show that using sig figs, okay? So we went into sig figs and did some examples of those. And remember, from now on in this class, you always need to have sig figs in your mind. Every single calculated answer you give should have the correct number of sig figs, okay? Now what we're going to do is we're still going to be talking about measurement, but now we're going to talk about scientific notation. Some of the numbers that we're going to need in this class are going to be huge numbers or really tiny numbers, right? Because we're talking about atoms, and atoms are super, super small. So if we're measuring the width of an atom, that's going to be a terribly tiny number. Or if we're talking about how many atoms are in a sample, we're going to be talking about a terribly huge number, right? In the trillions. So sometimes we need a way to write these really giant numbers that might have 17 or 18 zeros on it in a more workable format, and that is called scientific notation. So here I'm using an example of a smaller number, an easy to understand number, 65,000. It only has 3 zeros on it, right? So when we convert it to scientific notation, it's honestly about the same size. It takes about the same amount of writing. But think about if you're writing a number that has 17 or 18 zeros and how much space we're going to save and time we're going to save by knowing scientific notation, okay? So, how do we do scientific notation? Well, what we're going to do is we're going to take our great big giant number and we're going to move the decimal until there's one digit to the left of the decimal, okay? And then however many places we had to move, however many numbers we had to move to get there, that's going to become our exponent, okay? If we have a large number that we are converting, meaning bigger than 1, such as in our example here, 65,000 is bigger than 1, then our exponent will be positive. If we are converting a small number, so something that is less than 1, then it will have a negative exponent, okay? And when we write this, we're only including our sig figs, our significant figures, okay? So let's take a look at our example. We've got 65,000. Okay, this number has 2 sig figs because they have trailing zeros, but there's no decimals, so they're not important. They don't count. So only the 6 and the 5 count, so 2 sig figs. Okay, so in a whole number like this, the decimal is understood to be right at the end. We don't write it, but it's understood to be there. So how many times do we have to move this so that the decimal will have only one number to the left of it? If we start here and we go 1, 2, 3, 4. Okay, I had to move it 4 times, and then that would put the decimal in between that 6 and that 5. So it becomes 6.5, still 2 sig figs, times 10 to the 4th. I had to move the decimal 4 places to get it there, so it becomes a 4. And since it's a big number over 1, it is a positive number, 10 to the 4th. Okay. Now, when counting sig figs, if you are given something in scientific notation, you only look at the number that comes before the multiplication sign. Okay, the times 10 to the exponent, none of that counts in sig figs. Okay, just the 6.5. So there's 2 sig figs there. Let's look at some more practice problems. Okay, all right, so let's look at this one. Ooh, that's a nice big one, right? Lots of zeros in front of it. So first, let's determine how many sig figs are in this number. How many do you guys think? Okay, hopefully you said 2. There's 2 sig figs because there are all these trailing zeros. There's no decimal, so none of those count. Okay, so just the 2 and the 4 are significant, 2 sig figs. Okay, now our understood decimal's right here. Now we need to count and move that decimal so that it's right behind that 2. So how many times do we have to move it? If it's right here, we go 1, 2, 3, 4, 5, 6. So 2.4 times 10 to the 6th. Okay, let's do this next one. Okay, so that one was a big number, bigger than 1. So we had a positive exponent. Now let's do an example where it is actually smaller than 1. So if it's smaller than 1, that means that I am going to have a negative exponent. Okay, but we're still going to work the same way. So let's start by looking at how many sig figs do I have. Okay, how many do you think there are? There are leading zeros, but remember those leading zeros don't count because they are placeholders, but 1, 2, 3. So 2, 5, and 6 are significant. So we have 3 sig figs here. Okay, now we need to move the decimal so that it is right behind that 2. That way there's only one significant number in front of the decimal. So let's see. It's here. We're going to go 1, 2, 3. So it is going to become 2.56 times 10 to the negative 3 because we moved it this way. Okay? And then we can also take a scientific notation and convert it into a regular number. Okay, so this one has a negative, so we know this is going to be less than 0. So the understood decimal's here. We're going to move it 5 places. 1, 2, 3, 4, 5, and we're going to fill in all those places with zeros. Okay, so notice the decimal was here. We moved it 1, 2, 3, 4, 5 places. Okay. Our last example has a positive exponent, so this number is going to be bigger than 1, so we know we need to move that decimal to the right, okay, 4 times. So 1 puts it behind the 2, and then 2, 3, 4 fill in with zeros. Okay, so we moved it 1, 2, 3, and 4. Okay, if this makes sense to you, awesome. If you're lost right now and you have no idea what I'm doing and what's going on, get into contact with me so we can work on it together so we can get you where you need to be. Okay? Ask for help if you need it. All right. How do we calculate with scientific notation? How does that work? Okay, so notice we have 2 scientific notation numbers, 5.44 times 10 to the 7th, and we want to divide it by 8.1 times 10 to the 4th. Okay, so to do this, we're going to need to make sure we have a calculator that can work with us, because I realized I tried this on my calculator on my phone, and it does not work. My personal phone cannot do scientific notation, so we need to make sure that you have one. However, I did Google scientific calculator online, and it popped up with one that works. So if you need to do that, you can do that. If you have like a graphing calculator or a school scientific calculator that you have at home, those work, okay? But most phone calculators don't work, so just be aware of that. So let's grab your calculator now that you're going to use for doing problems in this class, and let's test it to make sure you get the same answer, okay? So to input this into a calculator, here's what you need to do. First, type 5.44, and then you should have a button on your calculator that is either EXP or EE, just depending on the model which one they use, EXP or EE. 7. So that button is telling your calculator that this is scientific notation. Okay. Now my phone has an E button, so I pressed that and tried it, but it doesn't come out right. So I'm not sure what that E means on my phone. I've got to play with it to find out. But it does not get the right answer. Okay. Next, press divide. Then type in 8.1. Then press that EXP or EE button again to say, oh, doing scientific notation times 10 to the 4. Okay. When you do that, and then you push enter or execute or the equal sign, depending on what calculator model you have, this is the answer you should get. You should get 671.6049383. Okay? If you do not get that on your calculator, then we need to work together. Okay? So either try Googling scientific calculator online and use that one. And you can bookmark that so you can use it all semester. Or if you are using a graphing calculator, you know your graphing calculator has the ability to do this, but you just can't figure out where the buttons are. Get into contact with me. We'll work together and we will get it figured out so that you can make sure you can do this, because you'll need it all throughout the semester. Okay? So make sure you can get that. But now we need to figure out sig figs, right? Because our answer has to be in correct sig figs. So let's look back at our problem. Okay, this number has 3 sig figs in it. There's no zeros to worry about. So this one has 3. This one, no zeros to worry about. It has 2. So since the least one is 2, my final answer needs to have 2 sig figs. So I have to round. So 671, so I'm going to take the 6, and then am I staying 7 or going to 8? Got to look at that third number. It's a 1. We round down, so 670. Okay, now if I want, I can write 670. That's a correct answer, and it has the correct number of sig figs. If you want, you could even write that in scientific notation, even though there's no need to. It's not a big number, but we still can, and we're going to follow the same rules. The understood decimals here, we're going to move it 2 places, so it would become 6.7 times 10 to the second. Okay, but either one of these answers, if I gave you this problem, either one of these answers are correct. Okay, whether you write it as a whole number or you write it in scientific notation, they both have 2 sig figs, so, and they are the same number.